Good morning. All right, this is the review key for section 8, all about right triangles and all that good stuff. So here we go. Match the appropriate ratio for the correct description. All right, so good point of reference is to have SOHCAHTOA on your paper at any point in time. So here we go. If I want the sine of x, so I find the angle x, it's right here. Sine is the opposite of the hypotenuse, so opposite is directly across or the furthest away from the angle. Hypotenuse is always across the right angle, so that'd be here. And so all we got to do is do the fraction here. It's 9 over 15, and then simplify it. So I can divide top and bottom by 3, and my answer is 3 over 5. That would be sine of x is equal to 3/5. Do the same thing with cosine of x. So cosine is the adjacent of the hypotenuse. Adjacent is right next to the angle. So I have 12 as my adjacent side over my hypotenuse, which is 15. Divide top and bottom by 3 again, and I will have 4 over 5. Boom. Alright, tan is of x. All these are of x. Is opposite over adjacent. So opposite is 9 over adjacent is 12. Divide top and bottom by 3, and I have 3 over 4. Okay. Make sure you simplify those fractions, otherwise you will get that wrong. Alright, moving on. Which numbers represent a Pythagorean triple? Choose all that apply. Remember, Pythagorean, the trick there is to actually just plug it into Pythagorean theorem. See if the left side equals the right side. Simple as that. So, grab my handy calculator. I'm going 15 squared plus 36 squared. I'm going to see what that is. And I'm just going to see if that is equal to 39 squared, and it is. It's the same thing, so the answer is yes. I would check that one. Alright, and then I go to the next one. So 6 squared plus 8 squared is 100, and I already know 10 squared is also 100. They both equal the same thing, so the answer is yes. Moving on, letter C. So same idea, you got to make sure you know which ones are the smallest in case they put them out of order. If you're not sure, you can always do 3 divided by 10, get an actual decimal. So this one's 0.3, if I didn't know that. 2 divided by 5 is 0.4, and 3 divided by 5 is 0.6. Okay, so I'm just making sure that when I plug in with Pythagorean theorem, I actually use the two smallest ones for A and B. Largest one should be for C. Okay, so from there you could do decimals or fractions. 0.3 squared though, plus 0.4 squared is this. Seeing as that the same thing as 0.6 squared. Oh, nope, not the same, so that is not a Pythagorean triple. Moving on. Same idea here. Okay, my two smallest decimals. So 0.32 squared plus 0.96 squared is this, and we should know 1 squared is still just 1. So obviously they're not the same, so the answer is no. Not choosing those. Okay, keep rolling. 8 squared plus 15 squared is 289, and 17 squared is, in fact, 289, so yes. Again, we got some fractions, so I already know 1/4 is 0.25, 1/3 is 0.3, repeating, and 5/12, just in case I didn't know, 5 divided by 12 is 0.416, so that is the largest. Here we go. So 0.25 squared plus 0.3 repeating. Instead of 0.3, I'm actually going to use a fraction to get exact. 1 divided by 3. I'm going to square it. So I get something like that. And then I'm going to go, I'm actually going to do 5 divided by 12 since it's a repeating decimal. And I'm going to square it. See how I shake out. Well, okay, so I got a fraction, so I hit my little arrows button. Gives me a decimal, so if I compare this one to the one above, looks like those are the exact same thing, so the answer is yes. Rolling on. Alright, so number 3, determine whether we've got this triangle is acute, right, or obtuse for each of the ones given, and for this you might need some graph paper, which you'll be given on the test. Okay, so here we go. Here's my graph paper, so I'm going to do the first one, A. Let's get some highlighters here. Okay, so for A, going to go ahead and draw an x and y axis. And then I'm going to plot some points. So we got -2, 3, -2, +3 is here's x. Y is -5, -4. And then z is 2, -1. Alright, so if I'm going to look at this, I didn't do that very good, but okay, so acute, right, or obtuse. Alright, well, clearly it does not look like it's an obtuse triangle because there's no angle that's larger than 90 degrees. However, acute, so not quite sure yet. Still, let's see what we have to do to figure that out. I mean, so there's a few different ways we can do this. We should know this. We should know if a squared plus b squared, essentially, like if we added those together, and that's actually greater than the third side squared, so the third side is smaller than the other two, that would make it an acute triangle. Okay, so if I do it the other way, a squared plus b squared is less than c squared. So in other words, c squared is larger than the other two. That makes it obtuse. And if a squared plus b squared is equal to c squared, that makes it a right triangle. It's essentially what it is. Now, are there other tricks? Absolutely. What I would do is this. I would find the distance of each side and then plug that in. Or I would use a little bit of process elimination. So we know that there's none of these angles are larger than 90, so it's definitely not obtuse. So it's either acute or right. And so for this, my trick would be if it's a right triangle, then you would have a right angle. Which means, oops, I totally misspelled that, yes, okay. Which means two lines would have perpendicular slopes, or opposite reciprocal slopes, right? So an easy way to do this was actually just check the slope on each side and see if you have any opposite reciprocals. So what I mean by that, okay, so if I drive from y to x, my rise over my run, rise 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Okay, so my slope is a rise of 7, run 3. All right, let's get the slope of this one. So if I drive here, I go rise 1, 2, 3, 4. I run 1, 2, 3, 4 the other way, -4. So my slope's a -1 over 1. So already I can check, are these opposite reciprocals? Well, no, so that means that's not a right angle. Okay, so what about this last one? Same idea. Let's just check it. Okay, so my rise is 1, 2, 3. I went down 3. And I ran 1, 2, 3, 4, 5, 6, 7 to the left. So that's actually positive. If negative divided by negative is a positive. So I look at this. Okay, these are reciprocal, but they're not opposite reciprocal. They're both a positive slope, right? So I'm still going uphill here, still going uphill here. They're not actually opposite reciprocal. So there's no 90-degree angle here, which makes this an acute triangle. Now another way to do that, using these formulas, would actually figure the distance of every side and then plug it into your formulas and see which one it followed suit with. I like a little bit of logic. Alright, so there was A is acute. Note on your test, it might not all be the same and it might be all mixed up, so make sure you actually do it on your tests, people. Alright, so the next one, B. Okay, B, here we go. So again, I'm drawing an X and Y axis. -5, +3 is X, 2, -1 is Y, and then Z is -1, -3. Okay, so again, when I look at this, sure looks like that could be a right angle, so I'm going to go ahead and go straight to the trick. I'm going to check to see if these two slopes are opposite reciprocals. Okay, so same exact idea as what you just did. Alright, let's check the slope here. So my rise is -2. My run is 1, 2, 3, -3. And negative divided by negative is a positive. That is a positive slope. I'm going to check this one over here. rise 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. So my slope over here is down 6, and then I ran positive 4. That simplifies. I can divide top and bottom by 2 to negative 3 over 2. So if I check my slopes, oh, look at that. Those are opposite reciprocals. So reciprocal, we flip it. One's positive, one's negative. So already I know there's a right angle right in here. All right, enough said. B is a right triangle. All right, last one, C. Okay, so we've got 3, 1. 9, 1, so 3, 6, 9, 1, and then negative 3, positive 7. Okay, all right, y'all. Clearly, there's an obtuse angle right here. I mean, a large obtuse angle right there. That makes it an obtuse triangle. I'm not going to do anything else because that is clear to see. Awesome. Okay. Done. Not so bad. It just takes a little bit of time. All right, number 4. The length of the hypotenuse of a 30, 60, 90 triangle is 7. Find the perimeter. Okay, cool. So if I draw a right triangle and it's a 30, 60, 90. So here's a 90, 60, and 30. They say that the hypotenuse the triangle is 7, so hypotenuse across the right angle is 7. Okay, find the perimeter. Okay, so if we find the perimeter, we need to find this distance and this distance. So I'm going to put 2 different letters up there. And then we're just going to add them all together. So you guys can just use SOHCAHTOA. So if I start this off here, let me highlight what we're going to go with. Just choose an angle to start from. Obviously not the 90, so maybe if I start with 30, here's my angle. Let's find x first, and then you have to use the 7. So you got to use 2 things that you know and 1 unknown. We're going to find the x first. Okay, so with that, if I start from 30, and you could have started from 60, right? So from this angle, what type of sides do I have? I've got an opposite, hypotenuse. I got to use sine. So the sine of 30 is equal to the opposite, which is x over 7, hypotenuse. All right, to solve, I multiply both sides times 7. And then I just type in the calculator and see what I get. Okay, so I have, let's clear that out. Clear. All right, I'm doing 7 sine of 30. Gives me 7 halves. Okay, so I'm just going to make that a decimal. It's 3.5. So x is equal to 3.5. All right, so right here we know that this distance right here is equal to 3.5. Great. Okay, so now we need to find y. Okay, so again, we're trying to find perimeter. So if I need to find y, again, from this angle, y is adjacent. You still could use the hypotenuse. So we use adjacent and hypotenuse this time round. So again, I'll highlight. We're dealing with this 30, the y, and now the 7. All right. We're going to have to use a different trig function this time around. So I've got a and h. I'm using cosine. So the cosine of my angle, which is 30, is equal to the adjacent of hypotenuse. Adjacent, which is my y, over my hypotenuse, which is 7. All right, same idea. Multiply both sides times 7. Y is equal to, let's figure out what that is. Type in the calculator. Good old calculator. 7 cosine 30 is equal to something weird. Decimal is 6.06. Okay. Blah, 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 blah. Okay. So, if I wanted perimeter, you've got x, and y right here is 6.062, yada, yada, yada. All right, if I want perimeter, we're just going to add up all of our edges, right? So 6.062 plus 3.5 plus the 7. Let's see what that equals. So I'm going to leave that in my calculator to get exact. Plus 3.5 plus 7. All right, gives me this cool decimal, right? So the perimeter is actually 16.562, blah, 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 blah. Okay. All right, so all I'm going to do, oh man, I look over here and I've got all these crazy radicals. I just type in each one in the calculator, see which one matches the same decimal. That'll work. All right, so if I do 7 plus 21 and I put a square root 3, I know my calculator, these give them something different. You just press the arrows. Okay, I get a decimal. Is that the same thing? Heck no, tech no. Close that one up. That's not it. Next one. All right, 21 divided by 2 plus 7 divided by 2 times the square root of 3. Whoa. Amazing. I get the same thing. Exact same thing. So hot diggity dog, B is my answer. No need to keep going. Got him. All right. Now this is a special right triangle. There's a formula for it. Could have done it actually a lot faster with the formula, but just use some trig. Trig will help you out with any right angle. Given an angle, a side and a side. All right. El Número 5, Tallahassee has a park in the center of town. The park is in the shape of a square with sidewalk extending from the northeast corner to the southwest corner of sidewalk. If the side lengths of the park are 25 feet, how long is the sidewalk around the nearest foot? Okay, so let's draw a picture. So we know it's a square park. They have a sidewalk from the northeast corner. So never eat soggy Wheaties. All right. Northeast corner, so that'd be over here. To the southwest corner is over here, so they got a sidewalk right there. We know the side lengths of the park are 25 feet. 25, 25, 25, 25. And all those are feet. Okay. All right, all right, all right. Okay, how long is the sidewalk? So we got to find this, x. Well, if it's a square, we should know that each of these angles are all 90 degrees. Well, cool. If that's the case. We should also know that this diagonal is going to cut 90 in half, which means right here is going to be 45 degrees, and down here would be 45, 45, 45. Okay. Okay, so if I want x, again, look at that. We have a right triangle. And so if we have a right triangle, again, you can immediately go to SOHCAHTOA. Okay, so choose an angle to go from, right? So I'm literally just going to look at this triangle here, right triangle. Look at this angle is 45. I need to know this side, so I already know that that's the hypotenuse across the right angle. I know this side is opposite or adjacent. It doesn't actually matter which one you choose. Choose either one. So let's just say I'm really good at labeling the opposite. We're going to use the opposite side and the hypotenuse from angle 45. So from that O and H, that deals with sine. Sine of 45 degrees is equal to the opposite, which is 25 over x, hypotenuse. And then we're going to switch places because x is the denominator, so 25 divided by sine, 45. All we do is plug that in the calculator. 25 divided by sine of 45 is what? Okay, weird decimal, press my arrows, 35.35. 355. Okay. Now, what do they want us to round to? They said round to the nearest foot. All right, so the nearest foot, people, would be the nearest whole number. So it's 35.355. Is that closer to 35? 36. That'd be 35. 35 feet. Done. Alrighty, number 6. This is good stuff right here. Okay. Find the value of x and y round to the nearest 10th. Okay. Alrighty. Let's do this. Okay. Oops, sorry. Okay, so you have one big triangle. They don't mark anything like you don't know that there's anything for sure, a right angle, which is unfortunate, but they don't. So in this big one, we know in any triangle there's 180 degrees. So let's figure out what this angle is. All right, so you know there's 180 degrees in a triangle. 45 plus 30 is 75. So let's take 180 subtract 75. It's 105. So actually, this angle over here is 105. All right, so if that's the case, question is, where do we go from here? Okay, so what we're going to do is this. This big one isn't a right triangle, which means you can't use a heartbeat or the boomerang. However, and this is a poor diagram, we have to be able to tell that this is 90 and 90 here and here, which is unfortunate. Again, this is a really bad diagram. Apologize. Okay, so if these two separate triangles are 90 degrees here, you're going to use SOHCAHTOA. Okay, so if we're going to use SOHCAHTOA, then let's start off with figuring something out here. So we got to start off with one of the triangles where you have at least two pieces of information of, remember, angle, side, and side. Okay, so here's your angle. You know this side. So let's figure out, let's say what this side is. Okay, so I'm going to figure this side out. I'm going to put, let's put a W there. Okay, so from my angle, W is opposite, 44 is hypotenuse. Okay, so if I opposite and hypotenuse, we're using sine. So I'm going to start off finding this side right here. So that's the sine of 30 is equal to the opposite, which is W, over the hypotenuse, which is 44. So I solve that. I multiply both sides times 44. And W is equal to whatever this is typed in my calculator. So 44 sine of 30 is 22. Okay, so W is 22. Great. Great, great, great. So let's put a little 22 right there. Great. Okay, so next. All right, we're looking at the smaller triangle here with the angle 45 and 20. Now you know an angle aside, and we're going to find out that other side x. Okay, so I'm going to do that. I'm going to use SOHCAHTOA. From the angle, I have an opposite side here, and x would be the hypotenuse. So again, I'm going to use sine again. So sine of my angle 45 is equal to the opposite, which now is 22 over my hypotenuse, which is x. X is in the denominator. We switch places. So x is equal to 22 divided by sine of 45. Plug in my calculator to see what we get. Decimal. Okay, 31.11269, blah, 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 blah. Okay, now we found one of the variables. They wanted you to find x and y, and they want you to round the nearest tenth. So x, I'm going to go ahead and round that to the nearest tenth, is 31.1. Great. Now we still have to solve for y, and y is a trickier one. Ooh, I've said 3, and I'm at 1. Okay, cool. So now if I got to find y, okay. Let's get some other colors here because this is already confusing. Okay, so if I got to find y, you're actually going to have to do two different problems to get y. Right, you can't use this as a 90-degree angle. It's not. It's 105, this big one here. So what we're going to have to do is I'm going to have to find this part of y maybe first. And just for the sake of keeping it separate, I'm going to write that as a. Then we're going to have to find this part of y, and that's b. And we'll get a and b, and we'll add those together. Okay, so if I start with maybe the green, if I'm going to solve for a, from the angle I have, you've got an opposite side, which is 22. We don't know a, we don't know, and actually is your adjacent side too. So if I'm using opposite and adjacent, I'm using tan. So it's tan of my angle, which is 45 degrees, is equal to the opposite, which is 22, or the adjacent, which is my a, I don't know, and then we're going to solve. So I switch places here, 22 over tan, 45. And I plug that in my calculator. Okay, so 22 divided by tan of 45 is equal to 22. Great. Okay, so if that's equal to 22, then I'm just going to put this 22 there. Great. So we got part of the whole part of y, right? Just from here to here is 22. That's not y, it's just part of it. Then we got to find out the little b there that we talked about. So from just looking at this triangle, from the angle we know, which is 30 degrees, b is the adjacent side. I'm going to use h, the hypotenuse. So if we have a and h, we're using cosine. So I got cosine of my angle, this time is 30, is equal to the adjacent over hypotenuse, which is b. My adjacent over my hypotenuse is 44. Okay, great. Here we just multiply times 44 both sides. Those cancel, and B is equal to whatever this hot mess is. All right, 44 cosine of 30. Oops. Is 38.105, blah, blah, blah. I don't know why I did it on a separate line. Okay, so if I come back over here, B is at 38.105, yada, yada, yada. Okay. Okay, so if I want Y, we're just going to add the green and the pink there together. So I already have that in my calculator. I'm just going to go ahead and add the 22 plus 22. That gives me my Y. All right, so in this case, Y ends up being to the nearest 10th, 60.1. Whew, that's a tough problem. Tough problem. All right, rolling on. 7, a 24-foot ladder is propped against a vertical wall. Makes a 66-degree angle with the ground. All right, so let's draw a picture. 24-foot ladder is propped up against a vertical wall. Here's my ladder. Vertical wall makes a 66-degree angle with the ground. All right, so 66-degree angle with the ground right here. How far is the foot of the ladder from the base of the wall? So we're trying to find this distance here. Around the nearest 10th. Okay, so no big deal. Again, you got a right angle here because it's with the wall. You got an adjacent side, not hypotenuse, so that leads you to believe that you're using cosine. So see, cosine of 66 degrees is equal to the x adjacent over the hypotenuse, 24. Multiply times 24. And 24 cosine of 66 is 9.76, said around the nearest 10th. All right, so the 6 rounds you up to 9.8. Feet, yeah, feet. Number 8. Oh, that's a good question. All right, so hopefully you've had time to read through this. The angle of depression of the closer side of the fence was 38 degrees, so you see that there. Angle, let's see, the angle of depression of the farther side of the fence was 25, so farther side would be way over here. Okay, that's the 25. The height of the balloon is 900 feet. They give you, estimate the width of the field. Here is your field. This is what we're trying to find right there. Okay, again, you got to use some SOHCAHTOA. It's really not too bad. You basically need to do this. All right, so you basically need to find the distance from here to here using this triangle. So I'm going to label that as Y. Okay, then you need to find the distance from here all the way to here. Label that Z. If I can find Y and Z, I'm just going to take those and subtract them. So Z minus Y will give me the distance W. Okay, so you got 2 right triangles to find those distances and roll out. Well, if you note in this problem, let's see if I can get something that's going to show up. Remember, you've got parallel lines here cut by a transversal. So it means alternate interior angles are congruent. So the angle from here to here is 38. The angle from here to here is also 38 degrees. Likewise, the angle from this transversal here, right? This angle right in here is 25. That means from here to here is also 25. And so we're going to solve 2 separate problems. So if I do like the orange one first, from the angle, from this angle right in here, 900 is opposite. I want to know this distance Y, which is adjacent. All right, I'm using O and A, that's tangent. So I'm going to do the tangent of the angle, which is 38, is equal to the opposite over the adjacent, which is, I don't know. All right, I'm going to label that Y. All right, we had that Y there. And then we solve. So Y is equal to 900 over tan 38. We just flip places. All right, so if I do that, I do 900 divided by tan 38. Okay, so Y is equal to 1,151.947, yada, 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 okay? Okay, now, so we got A, that's that, or sorry, we got Y, whatever, that's 1151.947, okay, that's this distance. Okay, so then we got to find Z. All right, so same idea. I'm looking at that green, same idea, this big triangle here. Oops. So we're looking at this angle right in here. This angle is 25 degrees, so it's the same as this one. Okay, so from the angle, we're still using the opposite, which is 900. We got to find this whole distance of the big triangle, which is my z. So I've got opposite, and I still have adjacent. This is still adjacent. Okay, so it's still tan. Tan of my angle this time is 25 degrees, is equal to my opposite, which is 900, divided by my adjacent, which is z. Flip places again, I have 900 divided by tan of 25. Same idea. Alright, so 900 divided by tan of 25. Alright, get a big number again. Blah, 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 blah. Okay, so you found the distance from here to here, which is the 1930.056. You found the distance from here to here, which is this. So if I just want the width of the field, we got to subtract these two numbers. And we want to go as exact as possible, so that's why I kind of left them in my calculator. So I already have this last one. I'm going to take this number, subtract the top one. So all I'm going to do is push minus, because I'm going to take my previous answer. And then I'm going to scroll up, press enter, and it's going to put in the whole thing so it's nice and exact. So my actual answer is this right here, 778. They said around the nearest foot. Yeah, so is this closer to 778 or 779? Answer is 778. Good old problem. Number 9, a wire attached to the top of a 55-foot telephone pole anchored to the ground. The angle of elevation is 54 degrees, so they already labeled that for you. That's nice. How long is the wire, right? So the wire is anchored from the telephone pole to the ground, which means it's this guy here, X, and they have a question mark for you too. So simple, right? SOHCAHTOA. Alright, so from here, the opposite side's here. Hypotenuse is here. I'm using sine. Opposite over hypotenuse. I flip places. I type in my calculator. Okay, and x is equal to 67.9837, blah, blah, blah. They said the nearest foot. Okay, so 67.9 is closest to 68. Done. 10. Again, they give you a diagram. It says, what's the angle that the rope makes with the ground? Around the angle, the nearest angle should be the nearest degree. That's cute. The angle of the rope is blank degree. So here's your rope. What's the angle? Your rope is from here to here, right? You want the angle at the ground. And they said, what's the angle of elevation? So again, elevation is just from your eyesight, line of eyesight, up to here, whatever you're looking at. So right here's your angle of elevation. So I want to find that. That's x. They give you two pieces of information. They give you the opposite side of that angle, and they give you the adjacent side. So we're going to use tan. So tan of my angle, I don't know, is x degrees is equal to the opposite, which is 150, over the adjacent, which is 285. Remember, if I want to get rid of tan, I'll find the angle. This is where we do inverse tan. So both sides, I'm going to go tan -1 to get rid of tan. And x will end up being whatever the inverse of tan is, 150 divided by 285. Right, so calculator all the way. Here's tan, so inverse tan, do second and tan. Do 150 divided by 285. And x is equal to 27.7585, blah, blah, blah. They want the nearest degree, so that'd be the nearest whole number. That's closer to 28. There's my answer. 11. You're standing at a point D, right here, looking across the room to point B. And they say lake, but that's your room. Okay. ADC is a right triangle, so that means this is your right 90-degree angle. And AC, so here's AC, it's perpendicular to BD. Okay, so that means there's a 90-degree angle right here. Point B is 5 yards from point A. All right, point B is 5 yards from point A, so 5 yards here. And, okay, so going back, point B is, my computer's doing something weird, 125 yards. Sorry. Shoot. Sorry, guys, my computer's acting up. Hopefully you don't see all that. Okay, sorry. And point B is 125 yards from point C. So over on this side, we're 125 yards. That's tricky wording, so be careful. What is the distance straight across the room from your present position? So if here you are, what's the distance across the room? So what's this distance right here is X. Okay, so if you look, and then we have a couple right triangles here. This is when you have to use a heartbeat, because we're inside the big triangle, and all we do is do this. You always start with the hypotenuse, which would be across the big right triangle right here. Doesn't matter which part you start on in the heartbeat, because we go on the inside the triangle. We go here, up, down, and back across. So you remember how we did that? Set up a proportion problem here. I went up 5 over X, back across X, and over 125. And then we cross multiply and solve. Alright, so X times X is X squared, and 5 times 125 is a big number. Okay, so X squared is equal to 625. I take the square root of both sides. And that's 25. So X is 25. Marcia wants to walk from the parking lot through the forest to the clearing. Okay, it's a lot. She wants to walk from the parking lot. Here's the parking lot. Through the forest. Here's the forest. To the clearing. Okay, she wants to go there. As shown, she knows that the forest ranger station here is 154 feet from the flagpole. Okay, so right here's 154 feet. And the flagpole is 350 feet from the clearing. Okay, so 350 feet there. How far is the parking lot from the clearing? And we're both in feet, so that's good. Okay, how far is the parking lot from the clearing? So we're trying to find here. Okay, so when and they gave you a little right angle there, it's hard to see, and a right angle here. So again, this has got to be either the heartbeat or the boomerang. If we're all on the outside of the triangle, it's the boomerang. Boomerang, let's do it. Okay, so again with the boomerang, you got to start with the hypotenuse of the big triangle. Oops. Okay, so here's your right angle, the big triangle. So the hypotenuse is here. Now, if we want to hit this side, that's going to be part of your boomerang. So your boomerang, whether you decide to start here or here when you throw it, it's got to be here because we got to throw it out this way. It's got to hit this side, come back, and then it's going to stop short because it's broken. All right, it's math. Happens. Okay, so remember when we do this, this entire distance, you need to know this entire distance, so just add 154. Oops. 154 plus 350 is 504. Okay, so in my proportion, 504 goes on top. My boomerang hits X, comes back across X, and then stops short at the flagpole. So that last little piece is just 350. Then we cross multiply and solve. X squared. All right. So 350 times 504. Ooh, that's a big number. 504 times 350 is a really big number. 176,400. Take the square root of both sides. 420. Okay, X is equal to 420. And there you go. Done. Last page. Determine what type of triangle is shown below. Okay, so kind of already talked about this. You just plug in this into Pythagorean theorem and see how it relates. What's going on here? Okay, so the smallest two numbers go here, so we got to put the 30 and the 41 squared here, and then the 55 squared here. So let's see how these compare. You got 30 squared plus 41 squared gives me this. 20581. All right, 55 squared gives me this. Okay, so we're going to compare these. This is a larger number than the left side. So remember this last one, the largest side. And when we square it, if it's greater than this side, this makes this an obtuse triangle. If it would have been the other way, if this number would have been smaller, this would have been an acute triangle. And if they would have been equal, it would have been a right triangle. So there you go. Obtuse. Alright, if the area of a square is 225, so the area is equal to 225 centimeters squared, what's the length of the diagonal? So you actually want to find the length of the diagonal. Alright, so I'm going to do this without that, right? So I'm going to do it again. Alright, so I want to know what this side is. Okay, well, the area of a square is simply the length times width, and we know in the square it's the same number. So another way, area is s times s. Like this side times this side gives me the area. So if I know the area is 225 and I want at least one side length, we're just going to take the square root of 225. It's 15. So the side length is 15, right? That makes sense because if this is 15 and this is 15, 15 times 15 gives me 225. So looking at this square, I know all the sides are 15. Okay, so if I want the length of the diagonal, well, it's a square, so you get 90-degree angles. Diagonal cuts that in half, which means half of 90 is 45 here and here and here and here. Okay, so then we got a right triangle, so again, we're going to use SOHCAHTOA. So just choose an angle to begin with. It doesn't matter here, just not the 90. So from this angle, I'm going to use opposite, and then x is my hypotenuse. So opposite and hypotenuse means I'm using sine. Sine of 45 is equal to 15 over my x hypotenuse. Solve, I switch places, x equal to 15 over sine 45. Look at my calculator, so I've got 15 divided by sine 45. Oop, let's make that a little. Okay, so 21.2. 1, 3, blah, blah, blah. That is the answer. That's the length of the diagonal. So when you look at your answer choices, again, just plug each one of these in your calculator to see which one it is. All right, so again, you won't have this calculator in the FSA, which means it'll automatically get you the decimal. Oops. Let's go like this. All right, so 25.98, not what we have. Next one, 15 square root of 2. There it is. Right, and clearly you would have seen that earlier when I typed it in. It automatically come out on my calculator, which is nice, but that will not happen on the FSA. You'll just have to type them in. There you go. Last one. Whew, long one here. Okay, segment AE is 8.5. So from A to E is 8.5. Okay, find the side length DC. Okay, so DC, they want you to find that. And the angle measure for ADE. So D is kind of like the middle ground there. AD, if I follow that. ADE. Okay, we're talking about this angle here. They will also want you to find that. I put a Y there. Okay. Well, good news. They don't have to tell you any numbers other than that because you should be able to figure this out. This top triangle is an equilateral because they have all the same angles. We know there's 180 degrees in any triangle, so if I divide that by 3, I get 60. So each one of these angles is 60 degrees. Well, great. And if you notice over here, the little arc mark is the same thing. So this is 60, and this is also 60. The angle becomes the easiest thing to find because you got 90 degrees here, 60 here, so 90 plus 60. It's 150. We know in any triangle there's 180, so subtract that from 180 gives me 30. So this angle is 30 degrees. When I'm looking in here, which angle shows 30? It's only these two, so you can cross off those. Question now is, how do I find x? How do I find DC? Well, again, use some trigonometry, peeps. We should know at this point if this is 8.5, over here is also 8.5. That's a lot, really hard to see, so I'm going to make this a little bit larger. All right, here was E, here's C, here's D. So we know 8.5 is right here. That's this distance right here. We know this angle is 60. We know it's a right triangle because this 90 would carry over here. And we got to find X. So a hot diggity dog, guys. You're going to use SOHCAHTOA again. All right, here's your angle. What type of angles you got? Well, opposite the right angle is a hypotenuse. Next to is adjacent. We're using an A and H. That would be cosine. So cosine of my angle is 60 degrees is equal to the adjacent of the hypotenuse. Flip places, x is in the denominator, so x is equal to 8.5 over cosine of 60. And then I type it in the calculator and I roll out with life. Okay, 8.5 divided by cosine of 60 is 17. It is 17. Wait. Sorry. Okay, so x is 17. Okay, so right here, DC is 17. So if I look at these two answer choices, which one's right? C. Whew, and we're done. Have a great day.